So we've hooked up the Milliamp Calibrator, and now we've just spun the transmitter around so we can see it with the camera. Jack, talk us about how I'm going to use that calibrator to check that transmitter.
Okay, as we talked about in the earlier bit, we're using this loop calibrator. It's set to source because we're going to use it as a power supply. And you have three settings here, 4 milliamps. You have a middle, which works off your knob, and 20 milliamps. You want to go to the middle and make sure it's turned all the way to give you the above 20 milliamps. It's like 125%. And we'll show you why in just a second. And then we have this meter in series, which you don't have to have, which I'll show you, but it's more accurate, especially if you're doing a bench calibration on an analog transmitter or something. You're going to want that for your documentation. We're hooked up with a pump here. This is calibrated 0 to 100 inches of water column. And we're going into the high side. The low side is vented. And for the purpose of this demo, we're just going to read the pressure on the display here. So right now you can see that it's at 0 inches of water.
If we were doing this in the field, we'd probably have a calibrated gauge to check against that, wouldn't we?
Yeah, and when you use a calibrated gauge or calibrated test equipment, any test equipment, you want it to be 3 to 4 times more accurate than the instrument that you're testing. So you're going to make sure we're going to close the vent off. Then we're going to slowly apply pressure. And you can actually see the display changing. So 12 milliamps is going to be around 50%. 12 milliamps is 50%. So when we get to 50 inches of water, you can see that we're very close. And you notice that this one is also reading 12 milliamps. But the reason I like having a separate meter is, like I said, it's more accurate. You would have a more accurate meter. But then also, if you notice, if you forget to put this to the middle and ramp it up, if you leave this on 4 milliamps or use it for a power supply, you're trying to put out 12 milliamps now and it's not able to. So because you have it restricted to 4 milliamps on your power supply. So always go 125% on those knobs. So then we're going to go on up, apply more pressure. Okay, so if you see there, we have 100 inches of water column. And we're going to end up with 20 milliamps. And like I said, doing a regular calibration, we recommend doing a 5 points, 0, 25, 50, 75, and 100, and then back down, because that'll...
And of course, if this was really in the field, we'd probably be using a smart calibrator,
right,
a communicator to do all this, and that would all of this, apart from the pump, would be on board the calibrator.
Right, and it's kind of now they have self-documenting calibrators. There's quite a few on the market that when you run through your test, you save it, and then you upload it to a database, and all your results are saved. You can print out, run reports, or whatever you'd like to do. This is just to show you that you can use the loop calibrator as a power supply to power up your transmitters when needed.